Hello everybody, welcome back to the training of the Modicon M221. In this video, we are going to see how to use the function block for counters. So let's go to the presentation. In this part, we're going to start with the small theory. Basically, the counter will count something that we want. You can count up or down. You can specify a preset value and you can reset the actual counter. Are the things that you need to know about the counter. You can count up, down, you can reset the value of the actual value of the counter that you have, or you can set a new value for the actual value that you have, that we call the preset. As you can see in here, okay, this counter has the count up, which is a input, which is name, and it has a countdown, which has an input for this name. And in order to use the output value for the counter, we need to use the percentage %c, the instance at .b. And the range for the counter goes to 0 to 9,999. Now, we have the possibility to define the preset with this percentage %c, the instance name, and .p. So when the value reaches the value of the preset, okay, the output D will activate. We're going to see this in more details, but I want you to know is that the counter just count up, down. You can make the preset and read the value in case you want to share the data externally. Then in the PLC we have a few states when you had call restart or one restart, and you can make these steps using the percentage S0 and percentage S1. And when you have a call restart, the value of the counters goes to 0, but if you have a one restart, it doesn't affect the actual value of the timer. Now, here we have a limitation if we want to count something bigger than the value that we have seen here, from 0 to this value. If we want to count something bigger than that, probably the best solution will be to do something like this, using the operation block that we see in the past. So basically what we have is the count up. We can use the trigger to add the number 1 into this register, to add 1, to subtract, to count down this in order to reset this part. This could be like a workaround in case you want to count more than the value that we have the limitation of the actual counter. So let's continue with the presentation. So in order to add the counter in our project is very simple. We need to go to this icon over here that includes all the function blocks that we have. Then we need to go into this one that has the 1, 2, 3. This one is the function block for the counter. When you click on the function block and click in where you want to locate, this is the representation of the counter. You can see here that you have the R for reset, the S for set the preset value into the actual value of the counter. Okay, you have the count up, count down, and then we have these three indications that the ones that we require most of the time is this one, the D when it's done, when we reach the value of the preset that we have defined it. So let's continue with this. When we double click on the function block that we have, it will appear at the bottom the counter properties where all the counter instances are located. And here you can see that you can define your own preset. Another way is to go to the tools and access to the counters that we have. So this is important because we can predefine the value of the preset, okay, as a static, but we also have the possibility to link a percentage %NW variable to write and change the preset value that we want. In case, for example, you want to count something, uh, the amount of times of this is going to that is something that we're going to do in this exercise. The count, the amount of times that a motor has been turned on. So that can be a configuration, okay, that you can have on the HMI. So you can link a percentage NW on the HMI into this function block, okay, using the percentage C, the name of the instance, and the P for preset. So you can link the value that you want to reach the counter, but we're going to see that later. So now let's continue with this. And this is what I want to show you. This is what I meant. So if you can link a percentage NW variable that you can use in an HMI or the graphic display for the Modicon M221, which is this one, DMH2GDB. And in order to do that, you will need to link that percentage NW variable into the instance of the counter .p, which is P for preset. So you can configure externally without using the software, the Machine Expert Basic, the actual timer that you are using. And if you want to read the actual value from the counter to show that in the HMI, it's very simple, similar. You just need to move the actual value of the counter into a percentage NW variable. And this is how you can do it. You need to assign the percentage NW to the instance of the counter .b, b for value. So let's continue with this. And now let's make the exercise for the implementation. Okay, but before doing this, let me just show you on the software an example I have done. So uh, this is very simple. This is the instance. In order to add the counter, you just need to go here, 1, 2, 3, this one are another counters we're gonna cover later, but this one is the one I want to show you. Once you click where you want, you can add the counter, okay. And then if you double click on the counter, you can see the counter properties, and in here you can change the preset of the counter. Okay, apply, and you should see the change over here. Okay, this is how you should do. So basically here you can see that you have the R for reset, then the other ones. So if we simulate this part, just to show you quick, and then we make the implementation. Okay, good. I have an animation table here. So you can see here that I have the counter, the preset, linked to a percentage NW30. So let's play the controller. There we go. It moved the preset value to here. You can see the preset is 0. So if we change this percentage NW, and I believe I got it over here. Okay, I'm going to change this to 10. This MW will be linked to the preset of the counter. So you can see here the preset now is 0. And if I press count up this one, it will start increasing the value. Okay, and this one count down. So you can see. Now let's increase a few. There we go. So if you use this one, the R, it will rest the actual value. You can see here the actual value .b, which is linked to the percentage NW31. You can see here counter value. Okay, if I press this one, the actual value that is also over here will be to 0. And there we go. Now you can see here. Now if I use this one, the set allows me to set the actual value to the value that I have on the preset. So if I press this one, there we go. The preset has moved also to the value, and this one is activated. Okay, preset reach. I'm going to cancel this and reset the value. And there we go. So this is how the counter easily works. Okay, and you also have the workaround in case you want to reach a higher value than the one that I showed you before over here in the presentation. Here, in case you want a higher value, you can use this. But now let's go into the implementation. The idea now is to count the amount of time that the motor is activated. Okay, for example, if you have a motor that has been turned on too many times, I don't know, 2000 times, you can activate an alarm to call the service or something similar. In this case, when we turn on the motor 5 times, we will execute an alarm. So just to use this counter. So let's continue with this. So when the output percentage Q0 is activated 5 times, we will activate the alarm 02. The only way to recover this if antenna for the alarm inter. Okay, perfect. So let's go into the software. Okay, this with the implementation. We are going to work with the previous application that we have. Let me just go back over here and check the simulation. Perfect. So what we need to do now is to go into the PRG underscore MGMT and add this logic in our system. We are going to create these variables. Okay, so let's start doing that. Just open the previous one. Okay, let's start creating these variables in our software. So programming tools, memory management, memory bits. This one should be the percentage M20, CMD underscore counter reset. And then this one, indication counter reached. Good. Now the other ones, the percentage NW11 and percentage NW0. Okay. We need to go to memory words. Okay. Save this. You can go to apply or just go to another window and then press 1. Um, okay, I have already completed this one. Okay, which is good. Configuration counter. Da, da, da. CFG counter motor. Okay, apply. And perfect. So once we have done this, we need to go to the PRG management, if I'm not wrong. Yes, management, and change what we have done in the past in the rank 1, this, that we have used this example to, no, this one is for the other things, for the function block. No, we just need to add this part. So let's add a rank, and here let's just add our counter. Okay, just drag and drop. Now we need to use the counter for the motor. So each time the motor is activated, counter up, percentage Q0.0. Okay, we need to activate the count up of this. Then the reset, let me just go back here, the presentation, counter, and 20 and 1. So let's go back here, 21 and 20, just to reset this. Okay. So what I have done here is to configure, just to drag the counter into the program. We're going to take into account the amount of time that the motor is executed, okay? And when it reaches the value that I'm going to configure, okay, we can directly select here and change to 5, but the idea is to link a variable into here. So let's continue this part, apply. Okay, so when this is activated 5 times, it will reach this, it will activate, and this is the one that we need to use for the alarm. Let's continue with this. So now what we need to do is to take the right streak for this one to reset the counter. Okay, so let's go back in here. There are different ways to do it. This one is just one example to do this. I usually use the operation block instead of the counter, but it depends on what you want to do. So in this way, when it reaches the time, it will reset again the counter. But what we need to do is to activate alarm. So we need to use this one on the alarms. Then I'm going to do that later. Let's see what else is missing over here. Perfect. So what we need to do now is to configure this counter. So far we have just put the counter in there and configure one preset. But if we want to make this preset variable, we need to add this part over here. So let's go back into the configuration here. I usually do the configuration over here in a different POU, but in this case, let's just put it over here. So short the operation block, another one. We need to link this. Now, let me just check which are the values that we have used. Indication would be the percentage NW0. So we need to move the percentage NW0, the value that we have on the instance 0 dot b for value, as you can see. And now if I want to send a new command, I need to use the percentage C0 dot p for preset colon equal percentage NW21 if I know wrong. No, let me just double check what was the variable and 11 current counter. Yes, perfect. So this is the variable that we need to share to the screen to change the actual counter, and this one is the actual value of the counter. That we're gonna see that later. So this one is how you can use the counter. This one is how to configure the counter, and this one is how to read the value from the counter. Now we're gonna implement this to activate alarm. So in that case, if we follow our example, what we need to do is to go to the alarms and assign over here where it's open that variable. But let's just go to the presentation in case I was wrong. Okay, I know wrong. So we need to use this one, the percentage M21. So let's go back over here, change this and assign the percentage M21. So when you reach the value, it will activate the alarm. And in the general alarms, there is already the alarm 02 to activate the alarm. Okay, so that's it for this part. I leave you to test it. Okay, so what we can do now, just to show you, is that we can use an HMI. In my case, I'm going to use the operator terminal expert. What I'm going to do is to select this one, which is the one I like. Going to select the driver to communicate to the PLC over Modbus TCP. Modbus TCP. Okay, I'm going to define here as the PLC underscore M221, just the name, and the configuration will be IP address. The IP address of the equipment is this one. This is the one I had configured in the past. I need to use IEC, and I believe that's all. Perfect. What I'm going to do is to read from the PLC, okay, the value from the counter. So I have the counter underscore value, another one counter underscore config, just a random name, just a quick example. In other videos, I'm going to show you how to do this properly. So the actual value, if I know wrong, is the percentage NW0, and the other one is the percentage NW11, if I know wrong. Okay, let me just double check this. If we go to management, again, see, yes, MW0 is the actual value, and this one is the configuration of the counter. So what I'm going to do is to connect to the PLC, download this example that we have done, and see if it's working or not, just to show you about the configuration and communication to an HMI. I haven't changed the port, my bad on there. Okay, now it's going to communicate with the PLC. Okay, PC to controller, override, yes, go on. Okay, PLC and run, programming, everything is in zero, as you can see over here. Now what I'm going to do is to go over here, define some elements in order to see the configuration. So I'm going to grab the numeric display, some text over here. Let's put this one configuration, the value, and in here I'm going to assign the variable. This one should be the configuration. Okay, in this way, as if a configuration value, the direction is two ways. Okay, and enable input mode. In the value is different because I don't want to write any information, so just put the counter selection one way, and in here you can see it's in red to just unselect this, and that's all. Let's simulate this, and hopefully we should be able to see 0, 0 over here. Okay, case in the other side. There we go. So let's go now into the timer. So if I configure this, whoops, over there, just 4. Okay, you can see that the preset has been changed. If I change this to 3, and it's changed. So let's start so you can see this much better. Da, 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 da. Okay. Okay, good. Perfect. So we need to activate the motor. Pa, 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 pam. Let's see how we can activate. I don't have any inputs located over here. But what we can do is to simulate that I have the motor. So I'm going to use, you can do this with the real PLC and the real IOs. In my case, I don't have that connected on the PLC. And 150, I believe I don't have that located anywhere. Okay, good. So now every time I press this one, you can see the value has increased. Another one. Okay, good. And now another one, and it goes in there. Okay, so now what we can do is to check what happened on the other side on the alarms. You can see the alarm is activated. Okay, and the only way to reset this is to acknowledge, but there is something here that I believe I didn't add it in the example, is that we need to reset this part because otherwise it's gonna be always in true. So what we can do over here, we can add on the alarms. When we have a negative flank on this one, a negative edge on this one, you can't reset this variable. Okay, that is something that you can add in your logic. I'm not going to do it, just leave it in there. Okay, but this is how you can configure the counter in the Modicon Entity 1 and how you can connect that into an HMI to configure and to read the actual value. So this is it for this part. Thank you very much for watching this video, and I see you on the next one.